All right, so this is exponential functions because you'll notice that the variable x is in the exponent. We're normally dealing with linear equations or quadratics where x is a normal number or a normal term. But this time, the variable is up at the top, so you'll notice it's 1/2 to the x power. And to the half power, to the half x, is actually an example of exponential decay. So we've done problems where we had exponential growth, meaning it starts off pretty small in the negatives, but when x is a positive number, it actually accelerates growth really fast. Where in this case, we're actually going to slow down the growth, and this is going to be exponential decay, meaning it's going to start off really big and then get small. And so just to kind of demonstrate how it works, let's make a t-chart or some type of data table. Okay, let's start with -2, and we'll go all the way up to 2. So -2 to 2. Okay? So if I plug in -2 for x, okay, we actually can't evaluate negative exponents. So what we need to do is, there's multiple ways, but this seems to be the easiest way to kind of explain it. The -2 exponent applies to both the numerator and the denominator. So it would be 1 to the -2, and then 2 to the -2 plus 2. Okay? And in order to evaluate negative exponents, we have to change them to positive exponents. The process is we move the affected term, so in this case 2 to the -2 power. If it's in the denominator, you move it to the numerator, and the same for 1 to the -2. So they switch places, and then what that does, it makes the exponents positive. So notice how it's 2 to the +2 and 1 to the +2. So now 2 squared we know is 4. 1 squared is 1. Okay, so 4 over 1 is 4. 4 plus 2 equals 6. So I put 6 there. So -2 comma 6, it's about right there. Okay. All right, so -1. Again, same process. When we have negative exponents, we do the flip, and so what we're going to have is 2 to the first over 1 to the first plus 2. Again, 2 to the first is 2, 1 to the first is 1, and 2 plus 2 equals 4. So I'll plug in 4 right there. So -1, 4. Okay. Then if we plug in 0, 1/2 to the 0th power, well, anything to the 0th power is 1. And then 1 plus 2 would give me 3, so 0 comma 3. Okay, if we plug in 1, 1/2 to the first power is 1/2. 1/2 plus 2 is 2 and 1/2, or 3/2, or 1.5. I would recommend using decimals because when you're graphing, decimals are a little bit easier to interpret and to graph. So at 1, it's at 1.5. And if you plug in 2, okay, let's go ahead and do that together because, again, fractions and exponents are sometimes a little scary. All right, so we have 1/2 to the 2nd power. Same process, the exponent affects the 1 and the 2. So it'd be 1 squared over 2 squared, which equals 1 over 4 plus 2. So it'd be 1/4 plus 2, which is 2 and 1/4, or this would be 9/4, or this would be, what would this be? Oh, by the way, that's not 3/2. Come on, Mr. Schwann. This is 5/2, and it's 2.5. Okay, so 9/4 is 2.25. Okay. So again, for graphing purposes, it makes it so 2.25 really close to 2. So if I'm graphing this correctly, it's going to look something like this. Okay. Notice how it starts off really high and then it actually swoops down to go low. That's called exponential decay because we read the graph left to right. And notice that this is something that we notice about exponential functions. We're introduced to this idea that, notice how close it gets to 2, right? So when I plugged in 1, it's 2.5. I plugged in 2, it's 2 and 1/4. If I plug into the 3rd power, you're actually going to get 2 to the 1/8. And then if I plug in 4, it's 2 to the 1/16. So it's going to get really, 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 really close to 2, but never actually touch 2. So in math, this is what we call an asymptote, which it's real definition is it kind of describes how it's going to continue its end behavior. It's going to get really close and not touch. But there actually are some times in math that you usually learn later on as you advance that the graph can cross asymptotes. So don't 100% subscribe to the idea that means the graph can never touch it or it can never cross it, because it can, because asymptotes actually just predict what its end behavior will be as it continues. So anyway, just to kind of give you a heads up on that. So anyway, that is what an exponential decay looks like. That's how you plug it in, and that's how you get the values. All right.